Okay, you are welcome today again. As we said earlier before, if you are watching this video, this video came as a result of a lot of complaints from most students I have met in life and some of my students who I've taught before. This student, basically, I'm making this video because of those who are in 200 level, whatever university you are attending. If you're in chemistry department, as long as you're in industrial chemistry, you're in chemistry education, and you're in pure chemistry, it doesn't matter whichever department you find yourself. I pray that this video meets you well as you prepare for your exam and also for you to understand the basis of organic chemistry as long as this life is concerned. Thank you. Continue watching. Like my video, follow and share. Thank you. So let's continue with the example of our first tutorial when we started with curve arrow. Remember I told you we are going to continue with the examples. And here we are with the examples on the board. Okay, follow me. I explain vividly for you to understand. Thank you. Examples of curve arrow. We shall be looking at example number 1 within a reaction between ethene and hydrogen bromide. So let's look at how the arrow curve goes from this reaction. So now there are two things to note in this movement of arrows. There's what we call a nucleophile and there's what we call electrophile, which I will explain subsequently in further tutorials online. Now in this case we are dealing with what we call a nucleophile, which means nucleus. It means that there is reach of electron. It means that electron can go out from that place. So now this is an ethene and this is a double bond. Note you that when you don't have money, you cannot give out. It is only the rich that can give to the poor. That is what happens in this chemistry. So pay attention and God bless you. Now there are double bonds here. It means that this double bond, there's going to be a breaking. This is an unsaturated compound. So when this bond breaks on this carbon, we're going to see the next step of this reaction. And you see the arrow is directly pointing towards the carbon. This is where the electron is reached. That's where the arrow starts from. And it ends at where the bond is going to be located. Now we see, as you see plus here, reacting with hydrogen bromide. Now these are two different atoms, hydrogen and bromine. We know that bromine is more electronegative than hydrogen. Because of that, the bond between the hydrogen and the bromine breaks on the bromine. The two electrons goes to the bromine. That is why you see I'm showing two dots. It means the same thing as a single bond as you see in the middle here. So let's move to the next step. Step 2. This is the first step. Step 2. Just as you saw the arrow above. As I say, the double bond breaks on this carbon. If you come here, you are now going to see a hydrogen as a result of breaking of bond. So whenever a bond breaks, there is another formation of another bond. So a bond breaking brings about a formation of another bond. Bill, I say very soon I'm going to use pigeon. Thank you, as soon as you follow my line. Thank you. Now, as the bond don't break on top of this carbon don't carry hydrogen. Can't leave this carbon deficient. This carbon no come get again. Imagine say you get 200 naira and you're hungry and you suppose go shop. You can't meet another person when you get. You can't give the 200 to the person. Now you no come get money again. So if you want go shop now and for credit you go shop. Now wetin this thing mean? This carbon now wey you see they carry plus means say e no get electron. E dey look for electron. This is called electrophile. Now, remember initially there is a bond breaking between hydrogen and a bromine. So this bond breaks on top of this bromine, leaving this hydrogen to go. This hydrogen that separated from this bond, as you are seeing, is taken by this carbon because this carbon is going to be rich in electron. Though you are not seeing it, when this bond breaks, I'm supposed to be putting negative on this carbon. It means that this carbon is going to be rich in electron. Now, this one now is going to be deficient. This one now, you know, will get enough electron, but this one will get enough electron. So this one will get enough electron. Now you carry this one when you get enough electron. But no need to be showing that one, except if you want more breaking, you can contact me. If not, as this one break here, this one becomes rich in electron, and this one becomes deficient. So this one goes, this one pick this one. Normally now, as you see, this RNA from this carbon to this hydrogen. That's what you are seeing here. Now this bromine we don't separate now, come carry minus. You can see this minus, you can decide to inside it in a bracket. There's no problem. Now the bond will break on top the bromine. Now be these two dots where you see. And this carbon now where bond break from, you know, can't get enough electron. So this bromine now can't get enough electron. So that enough electron now where you can't get, you can use a bond with this carbon where don't be enough. So this is a nucleophile and this is electrophile. So anytime you are moving arrow and you move from an electrophile to a nucleophile, it is wrong. You cannot move from electrophile to electrophile. So it is only those ones that are rich that can give out to those ones that are poor. So now let's look at the products of this reaction. Final product, we now have CH2, this hydrogen that is here before, and a bond between bromine and this carbon. So what is the name? If you know the name of this compound, put it in the comment section. Like, follow, and share for more updates. Thank you. God bless you.